Hey everyone, welcome to part 5 of the Azure Masterclass. And in this module, we're going to look at storage, not floppy disks. And really my goal for this module is to explore the basic types of storage in Azure, really around storage accounts. Things like the database offerings, be it Azure SQL Database, Postgres, MySQL, MariaDB, Cosmos. I'll cover those in a later module towards the end of the masterclass when we focus on database services. So this is really about the base types of storage that really power so many of the other capabilities in Azure. So we're going to look at understanding Azure storage capabilities, virtual machine storage, and then storage tools. And as always, if this is useful, please like, subscribe, comment, and share. So let's get to it. So firstly, there is not one type of storage. There's not one correct one that we should always use. If we think about it, we have different types of workloads. Those workloads have different requirements around both ephemeral and durable storage. Now, by ephemeral, I mean it's not durable. It's temporary. I could lose it at any moment. Now, we don't necessarily expect to lose it at any moment, but what I mean by ephemeral is it's stored generally locally on a particular node. There's some compute service that's provisioned, and that compute node has some local storage on it. So when we have these ephemeral workloads, often they're leveraging storage that's local to the node. If something happens to the node, if I deprovision my compute resource, be it a virtual machine, scale set, whatever, I'll lose the content. Whereas durable means, hey, it's protected, it's replicated within whatever blast radius I specify. But even if I shut down my compute resources, I don't expect to lose the content. It's durable, it's resilient. Now, the types of data we have vary greatly. I can think about, well, I have structured data. If I think about structured data, what we really mean by structured data is there's some kind of schema. There's some description that I have these particular columns of the data. They have certain attributes. Then I have rows that have those kind of set columns. So I think about that as structured types of data. We always think of relational databases, a great example of that. I might have just blocks of data. I might have kind of video files. I might have images. It might be music, might be CAD drawings, whatever. And we think of that as unstructured. So we have this data with a very rigid structure, and then we have data that really has no structure. It's just a whole bunch of bits put together. And then you can also think of there's like semi-structured. I can think about things like JSON documents. I can think about XML, where they're really kind of self-describing, but they have attributes as part of the document itself. So this is kind of like document type storage. And there's many others, but the point is we have different types of data within our environment. And depending on that type of what we want to store, we need different types of storage solutions. We want to be able to do different types of actions to that data. For example, some types of data, I want to put down a very small value, and then someone else takes it off, like a queue. We have others where we have key value pairs to quickly be able to look up things. We do have those just big blobs of data that we want to store. Sometimes I need it replicated across big distances. Sometimes I need to be able to index particular fields of that data. Sometimes I need to be able to randomly access the data. Sometimes it's just, hey, big write, big read. Sometimes it's just adding to the end. There's all these different types. There's different ways I need to interact with the data. Sometimes it's via APIs. Sometimes it might be via file-based protocols like SMB or NFS. So all these different requirements, which is why there's not one right solution for storage. We have different sets of capabilities so we can map to different needs. And so, unlike Lord of the Rings, there is not one storage to rule them all. We have different solutions based on what our requirements are. So I'm really going to focus on Azure Storage Accounts. This is kind of like the Azure Storage 101. This is that base building block, one of the first services we really ever had in Azure. Now, Azure does not use traditional storage area networks. Like in our on-prem data centers, we're used to these big, massive racks that are huge numbers of disks, multiple controllers, very resilient at a hardware level. Azure is not filled with SANs. Azure has compute clusters and storage clusters. Those storage clusters are made up of thousands of nodes with disks in them, and through software, it defines this very resilient, very rich storage stack. Now, I say mostly, we're going to talk about something called Azure NetApp files. Now, with the Azure NetApp files, it is bringing NetApp appliances, those filers, into Azure data centers to give me NetApp capabilities within Azure. And we'll talk about that later on. But for the most part, there's no SANs in Azure. Now, instead, it has this kind of three-tiered architecture within those storage stacks. I can think about, well, there's kind of a stream layer where it's actually storing the bits across the nodes. Then there's partitionings in how it actually organizes the data to start presenting it up. And then the front end layer itself. The front end layer actually is offering the services that we can go and connect to and then leverage. DNS is used for the namespace. So when I access these services, it's a DNS name. We can see that if I actually jump over for a second, if I go and look at a storage account, and then if I scroll, and what I can actually do is you can see I have this option over here of my properties right here. If I was to select the properties, you'll see it has a whole bunch of resource IDs. And then we have the blob service itself. And as you can see, they're always something.core.windows.net. You can see that kind of right here. And then what we have is the actual name of the storage account. So here you can see I've got this kind of, hey, this is my storage account name. So that makes up part of the total DNS name. So that's blob. You'll see file, well, file has a different name in itself. It has file.core.windows.net in that name. We can see, hey, there's Q, so we see Q, etc., etc. So we have the storage account name, dot the type of service, table, DFS for data lake, websites, you see .web and then a unique region identification. But they make up a big part of how we're going to interact with these storage accounts. So we have the DNS name, and then within there, if we're accessing certain resources like a container if it's blob, we'll have a partition and then the actual object we want to talk to. So it's this full name for the resource. Now the data itself, we talked about durable. Anything written to Azure Storage is durable. It's not just going to disappear if I reboot a VM or delete a VM, if a certain disk fails or a node fails. It's replicated intrastamp. So intrastamp is within a particular storage cluster, and there's multiple copies. There's never less than 3 copies of your data spread over multiple disks, spread over multiple racks. So this is synchronous. So I can think about this is, hey, within a particular cluster. So they're very close together. So I can do synchronous replication. The operation is not acknowledged until there are these 3 copies definitely written to storage. So I guarantee I'm not going to lose data. Then we have interstamp. So interstamp is typically where we replicate to another region. In this case, it's asynchronous, i.e., once we have that intrastamp, 3 copies written, it acknowledges back. Then in the background, it goes ahead and replicates it to the other location asynchronously. We have storage accounts. So this is the kind of building block of how we use Azure Storage. This is the top level namespace for storage services. We store it part of the DNS name. It's created in a region. So a storage account lives in a particular region. Now, as you'll see, I can replicate it to another region, but it still primarily lives in a certain region. And when we think about that, it's really important to locate our data in the right way. So I can think about, okay, Azure has lots and lots of regions. Let's just say we take a particular region for right now. And I know I'm going to have some compute services, we'll just call it compute, in region 1. And those compute services need storage. I need to put the storage account in the same region. So this is where, in that same region, I would create my storage account. Technically, could I create my storage account in another region hundreds of miles away? Yes, I could. But then realize the speed of light, speed of over fiber, it's even slower, would come into play. I want it in the same region, so when this compute service does some operation, which is what we really are caring about, it's a very low latency. It's low latency because they're very close together, they're in the same region. If I want to put my storage account in a different region, well, it's a bigger distance, a bigger latency, which is going to impact the performance of my workload. So we always think about when we create a storage account, where is it going to be used? Put it close to where it's going to be used. Now, if I was going to use it from, let's say, on premises, maybe I have a physical location and I want to use Azure Storage, then I would think about, okay, where's my location? How am I connecting to Azure? And then put it in the region that's closest to me from a connectivity perspective. And what I mean by that, most likely if I was using it from on premises, I'm using ExpressRoute. So ExpressRoute means, hey, we have the Azure Backbone Network. That Backbone Network connects to the region, and then it extends out to these meet me locations, these independent carrier neutral facilities that I have connected my network to as well. So depending on where my meet me location is, I would work out, well, what region's closest to that meet me location to give me the lowest latency between my location and the Azure region. Now, often that will be what's closest to my data center as well, but maybe not. If I've got multiple data centers, maybe my meet me location is actually further away than a region that's close to me, I want to get it close to the meet me. Otherwise, I'm just, hey, latency there and then latency back again. So I think about, hey, okay, if I want the quickest, the lowest latency connection, use a region that's closest to the meet me that actually connects my facility. And hopefully, normally, your meet me would also be close to your location, so it'll be close to the closest region. It's all about making those distances smaller so we reduce those latencies. That's really kind of the key point. So we create these things in a region. If I actually go and look at, for example, storage accounts. So if we're here looking at our storage accounts over here, when I go and add one, yes, I select kind of a resource group to store this thing in. Again, this doesn't matter. Resource groups, while they live in a certain region, are not a boundary. I can have the metadata for a resource group in South Central and create a storage account wherever I want. So I have to give the storage account a name. Storage accounts are a little bit weird. It has to all be lowercase, no spaces, between 3 and 24 characters. And it has to be unique in the world. So if I just try to create storage account, chances are someone else has taken that. Also remember governance. Think of your naming convention. Maybe my first letter is always the type of service. Maybe it's storage account. Then maybe I put in the region. So I'm going to create this in South Central US. Then maybe something to do with the workload. So Sav Store 1. And it's checked. So that is unique. So then you pick the region. So this is what I'm saying. I think about what is the region where I want to create this. So in this case, it's South Central. So what I'm doing here is I'm saying, hey, I want this in South Central, which also means that the compute service I intend to use this with, I'm intending to put those in South Central as well. I don't want to go and access from somewhere else. So that's the first part. Storage accounts live in a region. But I can have various types of resiliency, and this is super important. So we talked about we have a stamp. So I picked this storage account. Now, realistically, what's going on behind the scenes is we have those storage stamps. So this is essentially being powered by a big cluster with lots of racks. And what I can think about, there's something called locally redundant storage. So with locally redundant storage, I can say LRS, I always have 3 copies of any piece of data. I don't have to do anything to get that. That's the lowest form I can possibly get. So I'm resilient against any particular disk or node or even rack level failure. There's still 2 other copies of my data. So that's locally redundant storage. But this is all within one storage stamp. Now, obviously, it's all within the one region when we talked about kind of the region. And also, for more and more regions now, there's something called availability zones. We talked about that in the resiliency section. Availability zone, redundant, cooling, power, communication. So I could also think about, well, maybe I have different availability zones. So the next type of resiliency I can actually do is I can think about, well, there are storage stamps in each availability zone. So hey, we have another set of racks in each of the availability zones. So if I think this is kind of AZ1, AZ2, and AZ3. So if LRS is a copy, 3 copies within a particular stamp, then I can think about, well, ZRS, zone redundant storage, those 3 copies, it's still 3, but now the 3 are spread over the 3 availability zones that are exposed to my subscription. So I've got those additional level of resiliency. But now we think, okay, great, I can survive a data center failure. I want to be able to survive the region being unavailable. The Azure regions are paired. So for each of them, there is a matched region hundreds of miles away. They're always within the same geopolitical boundary. So your data is not replicating outside of your geopolitical boundary, so you have data sovereignty problems. But there's another region, so let's do it a different color. We'll say region 2. It's on the other side of the country, so East US, West US, etc., etc. And now what I can say is, well, once again, there are storage stamps over here. So with GRS, there's 3 copies in a particular zone. Then there's another 3 copies in the paired region. So that's GRS. So it's all in one stamp in the primary, and then it's asynchronously replicated. So it always has to be asynchronous. I can never really cross distances and use synchronous. The performance would be too poor because it would have to wait till it gets written, get the acknowledgement back before I can acknowledge to the app. It's not a great experience. So that's GRS. And when I do GRS, there's also a variant, it's kind of RA. That means I can actually read from this. I can't write to it, but if I had a compute service over here that really just needed to read, well, it could actually connect to this copy. Then you can start to get into these active-active type architectures. Then there's another one, and we'll use green. This is a combination of ZRS and GRS. Here, my 3 copies are spread, oh, no, that's not right. Here, my 3 copies are spread over the 3 availability zones again, and then I have the 3 copies in the other zone, but in one compute stamp. So that is GZRS, and once again, there is an RA variant if you want it. So now with GZRS, 3 copies, ZRS spread over 3 availability zones. Then once again, async replication, where I have 3 more copies. So for all these combinations, now obviously it gets more expensive as you move up. LRS is 1 cost, ZRS is cost a little bit more. GRS doubles it because I've got 3 copies here and 3 copies here. ZGRS increases it a bit more as well. If I do the RA, I get a second name I can use to interact with the replica of the data. Super important to understand what these mean. Make sure you're not replicating twice. If the app, the thing that's using this storage, is doing its own replication, I don't need to bother spending the extra money to let the storage do it as well. But make sure you understand those blast radiuses and then really what I can do with that. Okay, so we have those resiliency options and I configure that. So here back in my storage account, you can see I have my replication kinds down here. So if I select that, I have my LRS, ZRS, GRS, RA, GRS. The GZRS is available in certain regions, as is ZRS. If it doesn't support necessarily AZs, you may not see the ZRS. So you have all of these options available. And again, they might vary by region, vary by the type of service. Because, for example, if I change to premium, I'll talk about this in a second, you'll notice I only have LRS. No matter what type of account I select, I only ever have locally redundant storage. That means I would have to take care, if I need replication of the data, well then I will have to take care of working out how to get that data actually copied across. So I have various types of resiliency. I can connect via APIs and also other means based on the type. And what I mean by that is that, well, there's a REST API that I can talk to a storage account. But if I use something like files, well, that supports things like SMB, a file-based protocol. It supports things like NFS, a file-based protocol. Azure Blob, I can turn on NFS, a file-based protocol. So there's other ways I can actually interact with the data. And I guess something I probably should have called out is when I talk about this resiliency, this replication option here, there is actually another option for replication. And that's something you go and configure, but it's not at the storage account level. There's actually something called object level replication. So if I think about, if I have my storage account, so if I have my storage account here, I create these containers. So I might have a container 1 with a bunch of things in it. Then I might have container 2 with another bunch of things in it. And what I can do is I can set up object level replication to say, hey, I have another storage account over here in a different region completely. And I have a container over here. I can create a relationship to say, hey, replicate this container to that container. And then I can have another storage account over here with yet another container. Say, well, this one replicate to over there. And I can have up to, I think, 10 relationships between this account. Each container can only be in one. So that's something I can actually go and set up within the storage account itself. So for example, if I'm, let's go back over here again. Well, that closed. So here, if I quickly, I'll close this to a second. Actually, let's just copy that. So I'm lazy, I don't have to type that again. If I go and look at a storage account, and I say, hey, that's just, doesn't really matter which one I look at. I'll look at this one. I'll look at a certain type of data. You see, I have object replication down here. So you can see right here, object replication. So if I select that, what I can actually do is I want to set up a replication rule, and I can say, well, I want to replicate to this other storage account, I want to replicate from, in this case, I created a container called source to a container called destination. I can add filters. So a filter would be, for example, certain types of file prefix. It would only copy those. I can change what I'm copying. Is it everything, only new, some custom set of configuration? And then it will use asynchronous replication to keep them in sync. Now, the way it's doing that is it's using something called a change feed, which is a capability. There's also versioning, which we're going to leverage. And it's going to do all of those things to now replicate outside of those pairs, which is what the storage account resiliency will always use. So let's just get back to kind of where we were creating our storage account. So we have these different ways to interact: APIs, file-based protocols. As part of a storage account, there are these two all-powerful account keys. You want to be super, super careful with them. With the account key, I can do anything. The reason there are two is the idea is if I was using one and maybe got compromised and were to regenerate it, my app could switch to using the second key while I regenerate the first key. And I'll show these a little bit later on. I have different capacity, different IOPS, different throughput, depending on it exactly what I'm using. So again, if I go and look at creating my account, you'll see I have these options. For example, is it performance standard or premium? So premium gives me a whole different set of capabilities in terms of IOPS throughput. I also have these kind of account kinds. I have different tiers. I'm going to talk more about all of these. So we have these different options available to us. And then there's monitoring, there's logging. I can turn all those regular diagnostics on. So let's look at a bit more detail about the storage account. Okay, so we have that top level namespace we talked about. We pick the name. I create it in a region. And then there are different types. Now, I started to show this. If we jump back over to the portal, you can see here I have this account kind. Now I have storage v2 as the default, but we can see there are others. I can see, well, yeah, there's this storage general purpose v1, and there's blob storage. Essentially, at this point, you are always going to pick general purpose v2. General purpose v1 was the first type of storage that existed. Then they introduced blob storage to have things like tiering, different tiers of access, hot, cool, archive. Then that functionality got merged into general purpose v2. Then we have premium. So with premium, we open up a different type of account kinds. Now we have block blob storage and file storage. These are basically, the file storage is now very high performance file based, like SMB, NFS based, higher throughput. Same for the block blob, higher performance. So we get these different types of storage accounts show up when we hit premium. The premium, just regular storage, that's really for page blobs, which honestly we're not really going to use anymore. Oh, battery running low. We're not going to use those really anymore. We will focus on managed disks to actually get those types of performance. So the type of storage account you pick is going to depend on, well, what features do I want? If I just want, for example, queues and tables and things like that, then I could just pick standard and I would just use a storage v2. If I wanted the high performance Azure files, then I would change the performance to premium and I would pick file storage. Same as if I wanted NFS. NFS on Azure files is premium only. If I wanted the high performance blob capabilities, well then I'm going to choose block blob storage. So I pick the account kind that matches exactly what I need. What are the features? What's the performance? I have those different types of resiliency I talked about. LRS, ZRS, GRS, GZRS, the RA alternatives. And remember, those resiliencies are based on those kind of paired regions. If I select this for a second, it talks about what the pair regions are. So here I can actually see it walks through, hey, based on the geography, I can see the regional pairs. So I can see, hey, look, here's kind of one half, and then I can see the other half. And you'll see they're always in the same geopolitical boundary. It's never crossing. It's always kind of China to China, Europe to Europe, France to France. The only exception is Brazil. You'll see Brazil does replicate to South Central US because there's only one region in Brazil. South Central US does not replicate to Brazil. If you see, you can see, hey, North America, I can see North Central and South Central replicate. So it's Brazil to South Central, not South Central to Brazil. So we have those replications. Now, additionally, what's kind of cool is with that geo replication, in the past, you had no control of when it failed over. So we would pick the option. If we picked GRS, it would only fail over if Microsoft deemed, well, it's an emergency and we're going to fail the regions over, which I don't think has ever happened. What you can actually now do, if I go and look at a storage account that's geo-replicated, I'll pick, and you can do things like manage view, so you can change the columns. So maybe what I want to see is, I can see the secondary locations. I can pick things like, hey, I want to see the replication type. I don't care about subscription. So you can tweak what you actually see in here. So I'm going to add the replication type, click apply. So now I can see over here the replication. Hey, locally redundant, geo redundant over here. So if I look at this geo redundant one, it's going to show me, well, look, this is who you're replicating to. So East US is the primary, West US is the secondary. I can actually now trigger the failover. And what it will do is it will tell me, hey, look, remember it's asynchronous. It will say, look, the last time you synced was here. If you fail over now, anything after that time, you may lose. So I'll say, okay, I could type yes to do the failover. It's also telling me that, hey, if you fail over, it's going to become LRS. You would have to change it to GRS to replicate back the other way. Point is, you now have control of when that failover happens, but it's still only ever the paired regions. You cannot change it to go to a different region unless you actually go and do that object level replication I talked about. And then at a container level, I can control, well, what's replicating. Again, talked about API access, then based on the type, other things like SMB, NFS. We do have these two all-powerful account keys that I referenced before. So here, if I look at my storage account, I can see my access keys. Never ever share these, never put them up on a video where everyone can see them. With these keys, I can do anything. If these are compromised in some way, you would hit this icon. This will generate a new key. This is why there are two. I could be regenerating key 1, and while I'm doing that, I would switch over to key 2. So keep these safe. If they're ever compromised, regenerate them. That's super important. Okay, I talked about this capacity, IOPS, throughput. And again, I realize this is kind of the same side as the last one. I'm just now filling it out with more detail. This link here, let's actually go into it. This talks about those performance aspects. So this is the limits page. So this goes through all of the details about Azure subscription services and limits and storage. So you can see it talks about things like, hey, on a regular storage account, I can do 20,000 requests per second, maximum ingress, egress, etc. So there's various limits associated with that kind of standard that we have. If we scroll down on this side, too many windows, there's Azure blob limits. Again, you have things around the maximum sizes, access, requests per second, things we need to understand based on our application. If we then keep going down, we see things like Azure files limits, and now it differentiates between standard and premium. We can see 100,000 IOPS over here for premium compared to, well, up to 10,000 for regular. Then you have things like maximum egress, again, differences. So we need to understand our app workload to work out, well, what is the right type of account for us, queue, table, etc. So we have these different really capabilities based on what is it exactly that I need. We have different access tiers. So you saw when I was creating the storage account, it said, hey, default access tier, and it was hot. So the point of this, once again, is, well, I have data. I'm writing it to my storage account. But I use my data differently. Like I might have some data I'm constantly reading and writing to. So that's hot data. So I'm going to think about, hey, I have my hot data. So I pay a certain amount for the capacity, and you also pay for operations against it. So with hot, I pay more for the capacity storage, but less for the operations. Then I have data that's not used as much. It's cool data. So here I pay less for the capacity storage, but I'm going to pay more when I do operations against it. Both of these are still instantly available. So there's no lag, they're really stored in the same way. These are instant. So with both of these are instant access. Again, I'm just paying more for the capacity, hot versus cool, but I pay more for the operations, cool versus hot. Then there's archive. So with archive, it is not instant. It's actually written off somewhere else. So there'll be a delay. If I want to access data in archive, I have to move the data back to cool or hot. And there's like a priority if it's below a certain size where it's like 1 hour. So that's the priority option. But ordinarily it might be 10 hours. I can only move between a certain number of times within a certain time period. And the point of this is to optimize my money. So data I'm using a lot, I want in the hot tier. Data that I need instantly available, but I'm not using a lot, I can move to the cool tier. Data I need to keep, maybe for regulatory requirements or something, but I know I don't need to interact with, or if I do, it's not urgent. I can wait a day to access it. I would put in archive. And there are things actually built in that help me move my data on this for things like blob. So for blob, there's a lifecycle management capability. And what lifecycle management does is let me set rules. So if you think about, hey, I have this blob, that blob has kind of like last access time, last modified time. And so with the lifecycle management, I can say, look, if it's not been modified or accessed for a week, move it to cool. If it's not been accessed for 4 months, move it to archive. If it's not been accessed for 2 years, delete it. If it's premium, there is no access tier. So you can just do rules based around, hey, look, delete it if it's not used after this duration of time. These access tiers are super powerful. And I can see this if I go and look at one of my storage accounts. I'll just jump over to the portal. So here on my storage account, is it this one or is it a different one? Let's see. Let's try containers. No, it's the other one. So if I look, containers, I have images. And you can see here, we have this access tier. I have cool, hot, and archive. So the files in cool and hot, I could directly access. I could actually view that and see it. For the archive one, it would fail. because it's not instantly available. No, there's no option to kind of download that. Whereas if I go and look at one of the other ones, I have the download option. I would have to move the archive file into a different tier. So I would say, hey, look, change tier, move it into cool or hot. Once that's finished, it's actually moved, which again could take hours. Then I could actually view and open and use that piece of data. But access tiers, super powerful in terms of optimizing my spend. Use them and put it in the right tier based on how I want to interact, and use those lifecycle policies to make it do the work for me. And as I talked about, monitoring and logging. So money. The standard performance is consumption based. So if we look at this, we can actually go ahead and see how these things are actually built. So if I go here, we can see there's block blobs, data lake, managed disk files. It's got this very, very low price, that's archive. If I actually go and drill into this, then we'll see the data talks about those different premium, hot, cool, archive. So yes, archive is super cheap over here on the right hand side. But you see the price goes up, cool, hot, premium. But also what we should talk about is the operations. And this is what I was saying. So for premium, hot, cool, archive, you'll see hot is cheaper than cool. Premium is cheaper than hot for the right operations. So I'm going to pay more to actually interact with cool compared to hot, but I pay less for the actual storage. So that's an important thing to really understand around that. So you need to go and look at the pricing, understand the cost of these things as I'm thinking about the various storage types to best understand, well, what one works for me. Same for files. If I look at files and we explore the options, hey, there's storage, there's hot, there's cool, there's premium. I pay differently based on the access tier. I pay differently based on the operation. So here you can see again the hot and the cool, the operations, I pay basically double for cool to actually interact with it, but I pay less for the storage. So make sure you understand those pricing implications. And we really do want to use the right tier, the right type based on our requirements. We're going to pay more for better storage, but our app might need it. That's just kind of life. Now, my point is this is consumption based for standard. I pay for what I use. So the more data I write, the more I pay. It's pay as you go. Some of the premium performance is provision based. So things like Azure Files Premium. I pay based on the size of the share that I provision, not the data I write to it. So I say, hey, I'm going to create a terabyte share. I pay that price no matter how much data is written to it, because it's also based on the performance. So even if I only write a few files, I'm still getting that massive performance available because the performance is relational to the provisioned amount of space on it. So while normally for standard, yes, it's consumption based. I just pay for the data I write to the thing. For the premium files, it is provision based storage. I'm paying based on that provision space I'm going to use, no matter how much I've actually written to it. Block blob, even premium, is still pay as you go. Page premium is provisioned, but you're not going to use page premium anymore. You're going to use managed disks. So managed disks are always provision based. If it's a standard hard disk drive, standard SSD, a premium SSD, ultra, I pay for the size of the disk. Doesn't matter how much data is written to it, I pay the provision size. Also, don't forget about those operations, the data transfer. They come into the pricing as well. Then let's talk about the types of services I can use with a storage account, because there's actually quite a lot. Blob. Blob is just some unstructured data, media, CAD files, whatever you can think of, up to massive sizes. The first is block. So block is really designed around totally unstructured data, I want to write a massive amount of data, read a massive amount of data. Data is stored as blocks, and I chain these blocks together to create a block blob. I upload blocks, I download blocks, I read blocks. It's all in terms of blocks. I update at a block level. So this really is, hey, I just have some media, something that I need to read and write to, or some unstructured read and write to. It doesn't have a structure. There's no folders. Now I can fake it. And what a lot of tools will do is make the folder part of the blob name. So it'd be like images slash a name in there. So it looks like they can actually be folders, but it's a flat namespace. It's just using the naming of the file, I can make it look like there's a folder structure. Now, sitting on top of blob is the Azure Data Lake Storage Gen 2. So Gen 2 just uses blob. But what it does, it adds a hierarchical namespace to it. It's Hadoop file system HDFS compatible. It has POSIX style ACLs, so UID, GID to secure the data. And you can think of ADLS Gen 2 as this infinite store. And if you think a lot of data flows these days, you bring the data in and you store it. And then after you've stored it, you can transform it and load it into something else. The whole ETL type or ELT. Because storage now is so cheap, people, rather than bringing data in and transforming it straight away and then storing it, they'll just store the raw format that they got into Data Lake. The reason is, hey, in the future, I might have new types of insight I want to get from my data. But if I've already transformed it, I change what I care about and then store just the bits I need. If I have a new requirement in the future, I got rid of all the rest of the data. So if I get the data coming in and just store it to a data lake in its raw format, be it maybe JSON or XML or whatever that might be, then I transform it and then store it in like a Cosmos DB or Azure SQL database or something else. If tomorrow I have a new requirement, I still have all the raw data stored in my data lake. I can go and get it, transform it in new ways, and then load it into maybe a different type of data store. So this is super popular. If you look at any kind of data flows now, they're often going to bring the data, extract it from something, load it into a data lake, then transform it and then load it into the final actual destination data type. So that's super common to do. But we have blob, large amounts of data, unstructured. Then we have page. So page blobs, as the name suggests, is made up of pages. I think they're 512 bytes. So this is super good for random read-write access. Think of something like a disk with a virtual machine. This is how Azure virtual machines originally still do store disks. It's just it's hidden from us these days. But when I have a VHD used with a virtual machine, it's using a page blob. Because it's those 512 byte pages, it's very good to randomly interact with any point of the disk, which is what we need to do. So page blobs are all about random interaction with them. Then we have append. Append blob, you probably can guess, I can only write to the end of it. So very good for maybe log type scenarios. The rest of it is immutable. I can't change it. I can't change something that's already there. I can only add to the end of it. So we have these append blobs, super useful now. Normally I'm interacting with these through a REST API, but it is possible for blob to turn on actually an NFS3. So I can use NFS3 now. There's no POSIX ACLs. It's only available from a connected network, so there's no encryption on the wire. But I do get an NFS3, which is a fairly basic type of NFS, actually now with blob. Then there's tables. I think of tables as large amounts of data that's all about key value. And what I mean by that is it's not a fixed schema like a regular SQL database. So if we talked about our data types for a second, again, blob is really just a whole bunch of binary stuff. That's it. Again, the way I store it, blob is these big blocks. pages, these 5 12-byte pages I can randomly interact with, append, adds to the end. Table is really all about key values. So I have some entity that has these particular values. Maybe it's age, first name, last name. But every entity can have its own different value attributes I care about. There's no fixed schema for the table. It's not it must have first name, last name, age, whatever. Every entry, I just say, hey, it has these attributes to it. It's broken into partitions. So one of the things I'll see with tables is I have a partition key. And the partition is basically, if you think about, I have a lot of data in the table, the partition, or that key, is used to break it up into different kind of blocks of data that can improve how I then go and actually interact with it. It's probably easier to see it to really understand it. So I'm actually going to jump over. So what this I'm looking at, this is the Azure Storage Explorer. And actually I could jump back for a second. So you can see here, I can look at all my storage accounts. I'm looking at my blob containers. And right here, you can see how I'm looking at images, for example. And you can see the blobs. It shows me things like the access tier. I can upload, download, all kind of good stuff. Now you'll see, it actually does let me create a folder. Remember, this is not Data Lake Storage Gen 2. This will then just manipulate the file names as I actually store things into this. Again, there are no true hierarchy in blob, but it would just rename the files accordingly as things that go and get stored up here. But I can see my blob. Now let's go and look at a table. So let's see somewhere I've got some tables. Oh, I don't have any there. So let's scroll down to, we'll look at my VMS test. So I have a table here called scale logs. What I'm using this for is I'm writing a whole bunch of logs to detect scale actions in my environment. And you can see I have a whole bunch of column names. But essentially, when I add a record to this, I have to have a partition key and a row key. Remember, the partition is breaking it up into different partitions for my data, different shards. You might hear it called shards as well. And then I have a row key, the particular unique identifier of this particular entity. The partition key and row key must be unique in their combination. I can't have the same row in the same partition. And then I just have attributes. Now it's showing me attributes I've used for other records, but I don't have to put them in. I could add an entirely new property, cat name, and I could use it for this one. So there's no fixed schema. The point is, I'm just writing key value combinations to entities that I need for whatever purpose I might have. But there is no defined schema on this table. And it happens to be, because of the way I want to consume it, I have the same attributes for all of my records. New instance count, old, resource IDs, I have the same. But I don't have to. This is called like NoSQL. You'll commonly hear this referred to as. There's things like Cosmos DB. Cosmos DB would give me a similar set of capabilities to this, along with many, many others as well. But Cosmos DB has key value as one of its types. So I use tables if I have some need to store. It's not structured in the truest sense because there's no fixed schema, but it's those kind of key value pairs that I want to maybe go and look up and use from something else, kind of semi-structured. Then we have queues. Queue is just, hey, I want to put a piece of data on and then maybe something else take it off. It's first in, first out. So I write something, I can take it off. It's very basic. It's like get, put, peek. I can go and see what's on it. From an architecture perspective, you could think this could be really useful if I had some process maybe depositing data. Maybe it goes and actually writes the data. So if you think about this for a second, I have some process, and maybe that process is grabbing these great big images. And what this process does is it writes the image to blob. But then what it does is it writes an ID, the URI of the blob to a queue. Now there can be another process that takes the top one off the queue, first in, first out, and it's this ID, and it can then go and grab the actual blob from that queue and then go and do something with, maybe run cognitive services to detect what's in the image and then write the results to a Cosmos DB or something else. But the queue is essentially this first in, first out capability. So I have a queue. It's just a message is what I put in this. And it's this first in, first out message. And once again, we can kind of see this. If I look at my example again, I actually have a queue. And you'll see to interact, I can add messages. I can set it to expire in a certain time. ID 1. And likewise, I can then dequeue a message. It will take the top one off. So it's that first in, first out. Now, this is very, very simple. There are much richer capabilities with things like Service Bus. Service Bus lets me do a publish subscribe. I can have different topics. That's why one thing is publishing records, saying else multiple things can subscribe to them. It's a richer service. If I just need a really basic first in, first out, well, Azure Storage kind of gives me that. Then we have files. So Azure Files is primarily around SMB. So I can think about if I have files, it's SMB 2.1 and 3, but also now in preview is NFS, I think it's 4.1. So these are file-based protocols. Now, SMB3, we can actually do encryption over the wire. This is something that's requested by the client when it connects, but I can actually do encryption as part of SMB3. So ordinarily for Azure Files, I can only access it from the same region as the Azure Files share because it's not encrypted. I don't want to send it over the internet or over the wire. With SMB3, with encryption, I can access it from outside the region, from other regions. So we have these capabilities. And I'll talk more about kind of the ACLing I can do with this later on. But this is all about maybe I want some kind of shared space. It's SMB, it's NFS. With this, I can just have this, I create a share. So I can think about, hey, I have this Azure Files share that will say SMB. And now I can have multiple machines connecting just like they ordinarily would using SMB, and it's some shared area they can use. If I today had SMB shares on-prem, this would be a great replacement for that, maybe even an integration with that. But again, that's NFS as well. A share is one or the other. So I'm SMB or NFS. I cannot have one share accessible by both protocols. If it's NFS, it's UID, GID today. It's like the core feature set of NFS. It's not doing over-the-wire encryption today. It's not integration with Kerberos today. I think those things might come in the future. But all of these things are just part of the storage account. I have all of these capabilities available to me. I can even host a website. Now, it's not a fancy Flash website. If you only have static content, so HTML, JavaScript, cascading style sheets, images, I can actually say, hey, I want a website. So I enable it at the account level. I populate the content into this $web folder it creates. I can even hide it. So by default, it's going to have a name based on the storage account name, obviously in that kind of a zone. I don't want to make that my public one. So I can create an alias record that fronts that. So let's take a look at this if I can actually remember where I created this. So we'll go to the portal and let's take a quick look at where I created this. So look, containers, or I could just create, oh, so I've got a $web folder here. So that means I must have created it here. And what you'll actually see is if I look at the settings of my storage account, one of the things we actually have is this option around static website. So if I select that, you can see I set it to enabled. When I set it to enabled, it went and created that $web folder. It's giving me the endpoint. So that's how I would access it. Now, I would not want to give that name out. I would create a www.saviltech.net as a CNAME, an alias record, which resolved to that name. So I would hide it from the people accessing. And then I tell it, well, what I want the index document, the default to be, and then if it can't find something, what's the error document? Then I can actually go in, look at my containers. It created a $web container for me, and I put in my index document, my error document, and I put in an image. Now, this is what I was talking about. There's no such thing as folders in Azure, but it looks like I have folders in Blob, I mean. If I actually look at this file, if you look at the details around it, let's see, it's hard to see here. So what we'll do, super quick, we'll actually look in Storage Explorer. This makes it easier to see actually. If I look at that same file, so here we can see, okay, I'm in that web, I've got my images, there's the file in the folder. But if we actually look in detail at this file, we'll actually see the name, if we look, is images / then the actual file name that we perceive. So there isn't actually a folder. The folder name is just part of the name of the block. So there isn't actually a true hierarchy as part of this. But anyway, what we end up with is we put all these various files in. And now, if we actually go back, I think I saved that URL. If I just go and open up a new window and paste in, there's my really boring website. Welcome to the 90s. That's my old Saviltech logo I created when I was like 20. So there we go. I've had this static-based content just through my storage account. Now, what I didn't have to do as part of this is, you'll notice I'm accessing it just via anonymous website, but this container is not set to anonymous access. It's exposing it through the web connectivity, but I've not just said, hey, anyone could just go and see this. It's still private. It's just that special web capability is giving me that option. So if we go back up to my web, if we look at that as well, it's still private. So I'm not exposing anything through that. So if I want to create kind of a little basic website, I can just do it through my storage account. Not using the account key. So as I talked about, we have these two all-powerful account keys. I really don't want to be using those if I can help it. Ideally, I'll use Azure AD. So we're used to Azure AD at the Azure Resource Manager level for the control plane, but I can also use it at the data plane. Now, it's not for all services. If I go back and look at my storage account, one of the things I can actually do that makes this easy to see is I can look at my access control. If I look at my roles, what I'll actually see if I scroll down is there's really two sets that I care about. I can see there's storage blob data sets of roles. So you see these blob data owner, reader, and then contributor up there. So those three. And then I have also Azure Q data roles. So for these roles, I actually can use Azure AD based tokens that get automatically created for me behind the scenes, kind of this user delegation SaaS. You'd also see for Azure Files, there's share level permissions. Now, these are not ACLs on the data itself. These are ACLs using Azure AD accounts to be allowed to connect to a share. Now, if I just look at one of these, we'll look at blob data reader. If we look at the permissions, what we'll see is it's using the storage resource provider as we would expect. Then we have the regular management things, don't care about those. If we scroll down, we see data. And here I can see both sets of storage queue things and blob things, and then the file service from the kind of share perspective. And I can see there's various actions that we have available to us, like blobs. I can see add blob content, delete blob versions, filter blobs. So now I have these data level capabilities for within these roles. Look at queues. Nothing on that one. Let's look at queue messages. So add message, process message, delete, etc. So if I'm using blob, if I'm using queue, well, I can actually do permissionings using my Azure AD account. So that would be the preferred approach as much as possible. Remember, I'm saying my account. Remember, if I'm using Azure resources, I have things called managed identity. So the point is, hey, I have some Azure process running inside an Azure resource. This could be a VM. It could be a container, an AKS. It could be an Azure function. There's a huge number of different things, but I have some process. And what managed identity does, remember, is this particular instance of the resource gets an identity, this managed identity. Now, if we're talking about, well, okay, we have these storage services over here, and be it that blob or be it that queue, rather than having to try and store some key or access signature or something else, I can give this identity that's only a process running in this particular instance of whatever I created this identity for, a VM, a container, an Azure function, app service plan, whatever. In the ACLs of that particular resource, I can give this identity one of those roles, one of those data roles. So now there's no credential or anything to store. From a process inside that resource, I can just go and access it. If we go back for a second and actually look at these things, if I was actually going to add a role assignment, I could select, hey, I want one of these nice, maybe it's a blob data, let's say contributor. I can give it to one of these managed identities. Hey, I want to give it to a function. I'm going to give it to this function. So now that function and only that function gets that permission at this level. So this is for the storage account. But I could also have gone and set it at a lower level if I wanted to. If we go and look, for example, at our containers, and I'll go and look at my destination, I have access control here as well. I could add a role assignment. So it's just, hey, I'm going to give you that blob data contributor for that resource running in Azure at this level instead of the entire storage account. So I can be very granular with this, and this would be my preferred motion. So if I have resources in Azure wanting to use blob or queue, hey, this is phenomenal. I'm not messing around with access keys and signatures. I can just give them the role. But nothing supports that. Maybe I'm not ready to use that yet. Maybe it's not in Azure. I can't use a managed identity. I could use I could create a service principal and just store that service principal somewhere on premises in a vault, somewhere secure. We never put it in code. No matter what we're doing, we don't put tokens, we don't put accounts in our code. We never go and check that stuff in or anywhere else. Put it in a vault. I can also use shared access signatures and policy. So the account key is all powerful. It can do anything. With these shared access signatures, there's really two types. There's a service SAS and an account SAS. Service is specific to one of these services, blob, table, queue, files. Account is at the account level of the storage account, so it can be far more powerful in what it can do and how it can access it. I sign these with an account key, and this is an important point because how do I revoke them? So it's actually for the service SaaS, there's something called a service SaaS with a stored access policy. So I create a policy, and then I create a service SaaS off of the policy. So if I change the policy, if I revoke the policy, that SaaS is no longer any good. An ad hoc, which is the only thing I can do with account, or I can do an ad hoc as service if I don't want to use the policy, that's just using the account key. So the only way to revoke an ad hoc would be to rotate the signing key, because now that signature was signed with an account key that is not valid anymore. I rotated it. I went into the account keys and clicked regenerate. That's how I could revoke it. So what we would do is if we use these ad hoc ones, I want to keep them fairly short-lived. Just like we think about access tokens with Azure AD. It's short-lived. I would go and generate new ad hoc tokens for the service when it actually needs it. Now, the easiest way to actually look at these is, yes, there's some things I can do in the portal. So over here in the portal, for example, I can see my blob containers. I can look at containers, for example, and there's things at different levels and things I can see. There's an access policy. So here I've got stored access policies. I can add a policy, so I can create some of those policies. I can set the permissions, and then I could actually go and look at details of things. At the storage account level, I can create a shared access signature. Remember, this is an account shared access signature. So I can pick, well, what service does this apply to? I can be discrete. I can pick start and expiry times and what protocols, etc. I honestly don't use this very often. There's something called Storage Explorer. There is here a version running in the portal, and this gives honestly a superior. I can kind of right click and get a shared access signature in here. I can do all of those same things, but honestly I would use the tool version. So the tool version is really just superior. So here I could right click on a container and I could say I want to manage access policies. So here I could say, hey, I'm going to add an access policy. I give it a start and an end time. Be careful with start times. If you make it too close to now, maybe the clocks are off and it won't work. So just be careful with how you set those things. I can set expiry times and then the permissions just for this policy. Once I have a policy, well, then I could actually now go and create a shared access signature. And I could either do it ad hoc, so there's no access policy. I'm just going to define these things and it will just get signed with my account key. And so there's no way to revoke it short of regenerating the account key. Or I could build it, if I had an access policy, off of that. And then if I change the access policy, it would impact any signatures created from it. So let's just kind of test this. So I could actually create a shared access signature. In this case, I'll create a shared access signature for this blob. So I'll say, okay, I'm going to create a shared access signature. And here it is. It's given me this shared access signature. Now remember, this blob, this container it's in, is not available to the public. If we go back to our portal, all of mine are actually kind of locked up. Actually, where did I create that? That was in East US destination. So if I'm in my $web, remember I was in my images, there was that file. All of these are locked down. I'm in my Storage Explorer. There is no public access to any of these things. So jumping around a bit here. I just want to show you that, hey, I've not got any public access. But with that shared access signature, If I just go and paste this into the portal, it's this great big long thing, I can access the file. Because that shared access signature, well, I'm actually passing it a key that lets me use it. Now you can see it actually breaks down. It shows me things within the signature. Things like the starting validity, the ending validity times, what I can do with this token. You can see there's various permissions in here. And then there's the signature. This was signed with that key. Now you might look at this and go, this is the worst thing in the world. Anyone could sniff the network and see that and then use that shared access signature, because maybe that shared access signature is at the container level and I've got write access. So you're like, this is stupid. No one would ever use this, but this is HTTPS. And I find generally the problem people have with this is they don't understand HTTPS. So yes, that key, that signature was at the end of the URL. And so you might say, well, you're sending that plain text over the internet, but you're not. If I think about how we actually work on the internet, let's close that down. If I'm accessing something using HTTPS, so let's just say there's a www.savtech, whatever that is, .net, and then this secret key, but it's HTTPS. And then there's my computer wants to access that. So the first thing my computer does is it has to do kind of a DNS lookup to find the IP for www.savtech.net. Then over IP, it goes and talks to what is www.savtech.net. And what it's going to do is establish kind of a TCP. So far it's just talking to the IP address. It's just establishing. Then it establishes TLS. SSL. It establishes kind of the session, an encrypted session to that IP address. Then I can send it the URL over that encrypted session. So this key is never sent plain text. The way the ordering works is we'll go and find out who that is, establish a TCP session, establish an encrypted session, then I go and ask for particular things, which is when I send the URL. So I'm not sending the signatures plain text over the internet. It just doesn't work that way. I had people get all up in arms about, oh my God, what are you doing? You're killing everyone. And it's really not, because it's HTTPS. If it was HTTP, yes, that's a bad thing. People can see it. But as long as it's HTTPS, I'm encrypting this. This is not just publicly available. So these are my options. So if I have an application that wants to go and talk to storage, first case, if I can use Azure AD, if it's an Azure resource user managed identity, so not storing anything anywhere. If I can't do that, then I could use a service principal. If it's take blob or queue, so I can use Azure AD, use that. If I can't do that, then sure, I could generate a shared access signature, ideally use a policy, and then I can always revoke it, or I can use an ad hoc kind of key. If I'm using a key, okay, I'm still not putting the key in my code. What I would most likely do is I would have kind of Azure Key Vault, and I have things called secrets. So the secret would be kind of that shared access signature. I would store it in there. And then the app, when it starts up, this is where I can use managed identity. It would have permission, its managed identity would have permission to kind of the vault. It would be allowed to get that shared access signature, and it would use then the SaaS to access the storage. I actually might have another process that rotates that shared access signature, so the app can kind of go and get it. It would go and check, hey, is there a new one? I would have some overlapping window between the new SaaS and the old SaaS, so it never breaks. They could go and check in every 30 minutes or something. Is there a new SaaS? So some other process generates new SaaSes and writes them to the Key Vault. Many things I can do, but never, ever, 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 I do not put creds. I do not put keys in code or config files or anything else. They always go in a Key Vault. if you took nothing else away from this, that's kind of a super important point. As I talked about, don't panic about the SAS as plain text in HTTPS. It just doesn't work that way. So we'll talk about lifecycle management, but I kind of covered it already. The point is, remember there are access tiers, those hot, cool, archive. I want to move based on last access, last modified, to just optimize my spend. So the point is these lifecycle policies do that for me. It's going to help me automatically move things. I can go into the storage account, go into lifecycle management, and it would kind of do those moves for me. Remember, with premium, there are not tiers. So the only thing the rules can do is to delete after a certain period of time. Encryption. Everyone cares about encryption, obviously. So it's always encrypted at rest. Azure storage accounts, you create it, it's going to be encrypted at rest. By default, it will be encrypted with a Microsoft managed key. Now what you can do is you can use a customer managed key. So if I jump over and we look at the portal, what we can actually see in the portal, let's just look at my infra, you'll actually see a whole setting here around encryption. If I select encryption, we can then see, well, what is the type of encryption? A Microsoft managed key, so Microsoft is managing that key, or a customer managed key. If I select customer managed key, then what I can do is I can select a key from my Azure Key Vault. I can generate a new one as I go through this process, and then it uses my key to encrypt at the service level. That means I have full control. If I went and deleted that key, for example, I instantly lose all access to that data. No one can unencrypt the data. Now, there are certain protections put on so you don't accidentally go and delete the key. So there are things around undelete and tombstoning, but I essentially control the key. During creation of the storage account, I can't set it afterwards. I can also turn on something called infrastructure encryption. So this basically doubly encrypts it. This is always a Microsoft managed key, but now it will actually encrypt at the infrastructure, kind of the layer below the service. So the data is now doubly encrypted, once with either your key or Microsoft key, and then again with a Microsoft managed key using a different type of encryption algorithm, a different key. It's 256-bit AES, which is FIPS 142 compliant, but I can now have double encryption in case somehow there was some compromise of one of the encryption layers. The point is the data is always encrypted at rest. Now I can also have encryption scopes. So an encryption scope, I can go and add, I can give it a scope name. Let's say test 1, and again, is it a Microsoft key or a customer managed key? And then what I can actually do when I create a container or upload a blob or anything else, I can actually align it with a particular encryption scope. So now it's using a different key actually as part of that. So if I added a new container, advanced, you see I can actually pick a different encryption scope than the one that is just default with the storage account. So the point here is your data is always encrypted on the storage account. I can pick my own key, and I can even have different levels of encryption, different keys if I wanted to use a custom managed key for different containers, different blobs if I need to do that. Also at the app might do its own encryption as well. If I was running a database, well, things like SQL have transparent data encryption and other options. So there might also be encryption at the app level on top of that. Encryption in transit is up to you a little bit. Now I can enforce it. So remember there was different protocols, there's REST APIs. So if I use HTTPS, then it's going to be encrypted. So what I can actually say on the account level is I can say, look, I only want you to support encrypted communications. If I look at encryption again, remember this is all about the encryption of the data at rest. If I actually go and look at my configuration, well, here I could say secure transfer required. I've got that set to enabled. So here, this means, hey, I have to use HTTPS. If I'm using SMB, then I have to use SMB3 with encryption. So I can enforce that if I want. So that's an option. That's also exposed when I create a storage account. It's going to show me those options. So we have both encryption at rest, encryption in transit. As a special kind of features, we have snapshots. So a snapshot is a point-in-time view of blob or file share. It's not stored in a different place. It's stored in the same media as the original, but it gives me the ability to go back to previous points in time, and they're read-only. I can't change that content. We have things like incremental storage. So on those snapshots, it doesn't store a complete copy again, costing me money. It just stores the delta, the changes to the files between the snapshot and the next snapshot or now. So it's a very efficient way of storing. Using some of these technologies, we have blob versioning. So what it now does, it tracks at an incremental level. If I change a blob, it stores the old blocks that made up the blob, so I can go and see all the different versions of the blob. Every time I do a change to the blob, it tracks the blocks that changed, keeps the old ones, and I can now go back and look at the different versions of the blob. Again, I pay for the delta because it has to keep those blocks, so I pay a bit more money. That's all I have to pay. Soft delete. When I delete something, well, actually I can undelete it. I can pick a retention period. So I keep it for 7 days, 14 days. I can even now turn this on at a container level. So if I delete the container and everything in it, I can bring that back as well. Which gives me now, if I combine blob versioning and soft delete, I can do blob undelete. So this is using those versions and soft delete. So now I can just, like a recycle bin, hey, bring that back. So nice capabilities. So Azure File Sync is a nice little capability. Think about how I have existing file shares. I have Windows Server file shares, they're SMB on-prem. What Azure File Sync enables is a single cloud endpoint, so an Azure file share, and then multiple up to 50 servers in a synchronization group. What it's then going to do is replicate between them and the cloud endpoint to keep them synchronized. And it also gives me cloud tiering. So if, for example, I reach a certain capacity on a particular file server or server endpoint, it can tier that data off and just store it in the cloud. It keeps a kind of a thumbnail of the data on-prem on the file share, but it's not stored there anymore. It can go and fetch it back from the cloud. So what this looks like is, okay, I can think I have my on-prem file servers with their kind of file shares. These could be in very different locations spread all around. And then in my Azure, I have my storage account. And in there I've created an Azure file share. Now what I do is I create a sync group. On these servers, there's an agent to install for Azure File Sync, and these servers essentially register up, and then once they're registered, I can add them into the sync group. Then I add the particular Azure file share into kind of the sync group as well. So what's now going to happen is a replication is set up between each of those kind of file shares and the cloud endpoint. These are not talking directly. It's always talking via the cloud endpoint. So now I write data to here. Well, okay, I write some data here. It's going to replicate up to here, and it will replicate back down to here. Vice versa, I create data here, it will go to those as well. If there are ACLs on the files, they are maintained and replicated with the data as well. Now, something I didn't really talk a lot about from the Azure files is with Azure files, we can actually do AD integration. So with AD integration, what it will actually do is my storage account essentially, think about I've got Active Directory, my storage account kind of joins AD. I get a Kerberos identity for it. So now it can actually do ACLs based on my AD accounts. That's the other half. I talked about the permissions on the file share using an Azure AD account. Then the actual files can be based on accounts in my AD. So now if I turn on AD integration for my storage account, the ACLs are not only maintained, but if I access the file share in Azure, it's going to enforce the ACLs at a file level based on my AD account. So Azure File Sync, phenomenal to keep them synchronized. And again, if this got too full, it could actually remove data from its kind of local copy, but it would still see kind of a thumbprint of the data. And then if someone tries to access it, it could pull it back down and rehydrate. So Azure File Sync is a great way to keep synchronized between different locations and to have that resiliency that if something happened on-prem, I've got a copy of the data up here. If I didn't have the AD integration, I could create an IaaS file server and synchronize to that, because otherwise the ACLs won't get enforced. Yeah, if I just have regular Azure files without AD integration, the ACLs are maintained, but they're not enforced. So anyone with the files account could access it. So then if I created a regular VM that could join the domain, it would enforce the ACLs. But again, AD integration, accessing the Azure files will just enable that to work. So that's super powerful. So we have Azure File Sync. There's also, when I talk about file-based protocols, there's Azure NetApp Files. So this is a first-party offering. This is Azure. It's Azure. I can use Azure Resource Manager to create these things. It is Azure, but it's using NetApp hardware in the Azure data centers. This provides different performance tiers than what we would generally see with something like Azure Files. And this is where it starts to shine. This is all provisioned storage base. So I can have just standard, it's like 16 megabytes per second per terabyte of provisioned space. There's premium, 64 megabytes per second of 1 terabyte provision space. And then ultra, 128 megabytes per second of 1 terabyte provision space. So we have these different tiers. And the way it really works for NetApp files is I think about, okay, so I'm going to grab my NetApp files. And what I do is, firstly I create an account. So I create this NetApp files account. Then under that account, I create a capacity pool. Now it's the capacity pool that, as the name really suggests, I pick a certain capacity, a size, and I also pick kind of the level. So this is where it's kind of the standard, premium, or ultra. Again, you have kind of the 16, 64, and 128 megabytes for 1 terabyte provision. So if I did 4 terabytes, I think that's the minimum size anyways, 4 terabytes is the minimum size you can do. I get the multiple of that for the throughput. And then I go and create a volume, which is obviously a certain size. And it's using the capacity and the performance of the capacity pool that it's a member of. And when I pick that, yes, I pick the size, but I also pick the protocol, because this supports SMB and or NFS. That's right. I can actually have multi-protocol with NetApp files. I could have access via SMB and NFS to the same volume. And I have to pick a VNet. Because the way this works is that then these are not encrypted by default. So what happens here, if I think about, I have my Azure Virtual Network. So this is my VNet with all my resources on. A lot of services use something called a delegated subnet. They get a subnet from my VNet just for them. And that's what NetApp files does. Like, I think about there's multiple subnets my VNet's divided into. Well, it takes over one for kind of my NetApp. So anything in that VNet can access it or peer to it, just so it's a controlled, constrained set of access. I'm not accessing it via the public internet. It's within the VNet, so not doing this kind of cross traffic. That's kind of the point of it. There is actually encryption for NFS, but it uses Kerberos. So if you think about, I had a bunch of Linux machines, for example, you actually have to add entries into AD for those Linux machines to make it be able to use the encryption for the keys that it is leveraging. So I can do encryption over the wire, but it requires Kerberos AD integration to actually do that. Now, obviously, this capacity pool is also kind of in a region. One of the nice things I can do now is I can do cross-region replication. So NetApp have files in many, many different regions. They have pairings done at the filer level, and I can pick those pairings. I can do a dynamic service tier change. What it does is it takes the volume and I can move it to a different capacity pool. So if I have a capacity pool of maybe Ultra instead of Premium where it is today, I can move the volume to a different capacity pool of a higher or lower service level to dynamically kind of change that service. So we have that cross-region replication as well. So I could replicate to a lower tier like standard. If I actually failed over and used it, I could dynamically go to a different capacity pool with Ultra. So with SMB and NFS, uses delegated subnet. And if we actually look at the article for a second, so here we can see it's talking about, hey, cross-region. It shows you the replication pairs. So these are not the same as regular storage. Regular storage is just kind of a one-to-one. This is where they've set up replication between filers. So we notice there's multiple from South Central, so I have choices. I can pick the replication interval every 10 minutes, once an hour, once a day. You have those kind of controls available to you. So managed disk. This came about as originally the disks we use with virtual machines were page blobs. Those page blobs lived in a certain storage account. The storage account had certain limits. So I had to be super cognizant of how many disks I put in the storage account, or I'd hit storage account limits. This abstracts that away. It's still using a storage account. It's still using a page blob. I don't see it anymore. The only time I see it is if I do an import or export from managed disk. It creates a shared access signature, and there I can kind of see the storage account it's in. But to all intents and purposes, it's hidden from me. So I don't get to see those things. It removes worries around the IOPS of the storage account. And now the disks, the snapshots, they have become first-party Azure Resource Manager resources. Create them with templates, have ACLs on them, all that kind of rich experience I would expect. Now, I have 4 different types today. It could change in the future. Standard hard disk drive based, standard SSD, premium SSD, and ultra SSD. If we take a look at these, the whole point of these disks is we get different types of performance, and it's all provisioned. So the performance is all based on the size of the disk. So here's all the premium ones. They're all the way from 4 gigabytes up to 32 terabytes. And what you're seeing is, if you look at the IOPS and the throughput, they go up as the disk gets bigger. So what you're looking at is this kind of number here. Now you'll also notice that's focused on provisioned 120, provisioned 240, provisioned 500. Down here, provisioned 1100, 2300. But it also has this kind of up to. So what it is, these smaller disks up to P20 have a burst capability. Same for the throughput. So what you can do is, for a limited amount of time, you can actually go up to a much higher IOPS, much higher throughput, if it's available and if you kind of accrued a bit of credit, i.e. you've not used some of your base performance. But ordinarily, and again, that's not for the bigger disks. The bigger disks, the idea is, well, they have enough IOPS and throughput, they don't need burst. So you have this certain amount of provisioned throughput. Provisioned is that's guaranteed. I'm always going to get that provision number. The up to, it depends on other factors if you can get it or not. Premium is generally recommended for production. Then we have standard SSD. There's no bursting here. And what you'll notice is the IOPS is up to. The key point is it's not provisioned, it's not guaranteed. You should get close to it, but it's not guaranteed. This is why for production, this might be a little bit iffy because you're not guaranteed to get that performance you want. Then there's standard hard disk drives. Again, it's up to, it's not provisioned. This generally test dev. And then Ultra. Now, Ultra is special because if you look at all of the others, all of the IOPS, the throughput got bigger as the disk got bigger. Then one thing I should have pointed out, Premium SSD, it actually has a feature in preview right now that lets you actually change the performance, but not the size. Now, I pay for the performance I'm getting, but I could take a P20 and change it to a P50 in terms of performance. I'm going to pay the P50 rate, but I don't have to resize the disk. And then I could shrink it back down again and go back to paying the P20 from a performance perspective. So it's just a way I can boost performance temporarily, but I'll pay for the essential, the P50 for that duration. But Ultra is different. Ultra is actually independent dials. I have the disk capacity, I have the IOPS, and I have the throughput. Each of them are kind of billed independently. Because what I could say is, hey, I want a disk this size, but I want the full 160,000 IOPS. I want the full 2 gigabytes per second, even for a much, much smaller disk. So I can independently tweak these dials, and the IOPS and the throughput, I can actually change dynamically while it's running. I could, hey, it's a busy time, I'm going to crank up the IOPS. Hey, it's a quiet time, I'm going to crank them back down again. This vCPU charge, this is only if I have a VM that I've enabled for UltraDisk, but I don't connect an UltraDisk to it. Generally, they don't want you to turn that UltraDisk capability on unless you actually connect an UltraDisk. So the key point here is there's lots and lots of different types of disk available to me. I'm going to pick the one that makes the most sense. These really big databases I have that are high performance, I'm probably going to use UltraDisk for. Regular workloads, Premium SSD in production. Test dev, maybe standard SSD, standard hard disk drive. Again, obviously it gets more expensive as I go up the different tiers. But again, Ultra super good in that I can independently dial in the IOPS, the throughput, independent of that capacity. It's always based on provisioned, not the amount I write to it. I can expand them. So if I deallocate a VM it's connected to, I can resize the managed disk and then start it up again. So I can make them bigger. I would then obviously go into the OS and make the volume bigger on the disk that I've created. Only locally redundant storage. If I want any kind of replication, either I'm doing it from the compute service, like inside the VM, or there are ways I can take snapshots and then do a Delta-based copy to another location. So there are things I can do with that. If I have unmanaged disks, i.e. page blobs, I can convert them to managed, and you should do. There's really no reason to use unmanaged. I'm losing so much capability. There is this resiliency capability with availability sets. And I have to turn that on. I kind of turn on this additional option for my AZs, and it basically aligns them. And if we think back to an availability set, the point of an availability set was I could think I have 3 fault domains, 3 different racks, kind of fault domain 0, 1, and 2. And my VMs would get kind of scattered over the different racks. But But the challenge could be, I'm an unlucky person. I have storage clusters. So I've got storage cluster 1. Well, what if all of the disks for those VMs were on the same storage cluster and the storage cluster had a problem? They're taken down. So what aligning does is it actually makes sure that the managed disks for the different fault domains go to 3 different clusters. So fault domain 0 goes to that cluster, 1 goes to that cluster, 2 goes to that cluster. I only get that with managed disks, but it now does that alignment for me to make sure there's no single point of failure. So a storage cluster failure would only take down 1 rack, because each rack is going to a different storage cluster. So turn on that aligned option if you're using availability sets. There's also this max shares property if I'm using premium and ultra. So ordinarily, a particular disk can only be used by one virtual machine. I have a VM, I have a managed disk, and the VM connects to it and uses it. So with the premium, I think the P15, the P20 lets you have 2 connections. 30, 40, 50 have 5. Above that is 10. Ultra is 1 to 5. I have a max shares property. Now I could connect multiple VMs to the same disk. This appears as kind of SCSI persistent reservation supported storage. So I can create clusters. I could have kind of a Windows cluster, a Linux cluster. It supports those persistent reservations. It will appear as shared storage. I'm not having to use something like storage spaces direct to use a hyper-converged and then replicate the data. It's actually a single disk connected to multiple virtual machines. If the managed disk can be deployed to AZ's availability zones. If it's AZ aligned, the VMs have to be in the same AZ as the managed disk. If it's just regional, it's going to auto-align and put them in the same data center, essentially. But now I could have this shared storage using the same actual disk. So cool capability. Now I'm going to talk more about VM storage when I talk about compute itself, but quickly, a VM is provisioned onto a certain host. So these racks and racks of servers, a VM gets put onto one of them. Now, there's an OS disk. Ordinarily, it's durable. So what I mean by that is it's written to Azure Storage. It's a managed disk behind the scenes. It's written to Azure Storage. There's 3 copies. But some support ephemeral. If I have a stateless workload that I really don't care about, I can configure it to use an ephemeral OS disk. It means it will provision faster because it's using local cache or even now local temporary space. It's an option. But obviously if the host goes down, I lose that state. But it's going to be quicker to provision and it's going to have a lower latency because it's a local disk on the machine. Most VMs also have a temporary drive. This is D by default on Windows or /dev/SDB1 on Linux. I can change it if I need to for Windows. Basically what I would do is Windows puts the page file on it. I would have to move the page file to the C drive, reboot. Then I could free up the D drive, name it something else, E, F. Then I could add a data disk to be D. So I could change it if I wanted to. It's a scratch area, okay? It's local to the host. So if I think about the picture, I have a physical box. That physical box has a certain amount of local storage. A VM is created. Now, ordinarily, that VM has a managed disk for the operating system. Let's just say C, a Windows. What it also does is it creates a disk here for the D drive. So that's on the local box, whereas this managed disk, well, this is on Azure Storage. So it's locally redundant, there's 3 copies, it's resilient. This is temporary. It's a good scratch drive. We put the page file on for Windows. I could things like tempdb buffer extensions for SQL. There's things I can do. I'd have to write a process for SQL to check the folders there. If it's not created, then start SQL Server so that there's work. But I get this local, which is obviously a very low latency because it's local to the box. For the A series, this is a hard disk drive. For everything else, this is an SSD. I'll get that kind of equivalent performance through there. And then I can add additional disks for things like data drives, etc., etc. Don't put anything you care about. It's even got a data loss warning at the root of the folder. You're going to lose stuff you put on here. Again, that HDD SSD based. Can add additional data drives. The number I can add depends on the size of the virtual machine. So VMs have properties that control the number of data disks, the throughput, the IOPS. So all of these are part of the limits of the VM. So if we go and look at types of virtual machine just for a second, we know there's a massive number of types of virtual machines. If I just pick one for a second, we'll just look at the D series just for fun. You need to kind of pay attention because what it tells you is, yeah, look, the amount of temporary storage I get, the amount of temporary storage I get over here, then I have temp storage throughput, again, that local storage, then data disk throughput. And you can see how many disks. So I can have 8 disks, 16 disks, 32, and then the actual throughput, the IOPS I can get. So I need to be aware of those numbers. If I look at the E series, for example, we can see those again, temp storage, max number of data disks, max temp storage, throughput, etc. So I have all these limits I need to be aware of because the total performance I'm going to get is, yes, the performance of the disk, but also the performance of the VM itself. It has its own limits about what I can actually use. So it's no good assigning 32 massive IOPS disks to a VM that only supports 6,400 IOPS. It's just not going to work. So you have to consider both the VM's performance and the storage to work out what it could actually use. Now, some virtual machines have some additional types, like the L series. The L series actually has NVMe. So again, it's ephemeral, it's only temporary, but in addition to this regular storage, it also has kind of these NVMe that the VM gets an amount of it. It's local, so it's very low latency, super high performance. It is ephemeral. So the workload in here maybe pre-caches some stuff into it or uses it as a temporary working area. But if the host goes down, I lose that content. So it's super important from a VM to understand the difference between durable storage, like managed disks, and ephemeral, the temporary drive, NVMe, etc. Now, obviously, I can also use other types of storage. Now, I might have a storage account over here. It could be blobs, queues. I might be using a REST API. I might be using SMB or NFS. But that doesn't go over the data bandwidth. That would be used in the network capability. I'm using the total amount of network I have on the VM. Some VMs have burst capabilities. I talked about they have limits. Well, some of them now can actually burst up and get buckets. We're used to bursting on VMs of things like CPU with the B series. Well, now you can actually see, hey, look, I can burst the LS2 and also now the DSV3, ESV3. It's only in certain regions right now. This is a new thing they're kind of testing out. But they can actually go and burst beyond their regular amounts. And it kind of talks about, hey, the scenarios, how the flow works. You have this bucket of burst capabilities and how much you can actually burst up to. So it's kind of an interesting read. But it's the whole point that, hey, I have a certain amount of workload that's busy at certain points of the day. I don't need to have some much bigger VM to be busy 5 minutes a day. I can actually go and burst beyond what is my norm. If I need a volume bigger than the max size of a volume, which is pretty unlikely these days, but obviously I can add multiple data disks. I could use things like storage spaces for Windows to put multiple disks together to appear as one big disk. Do not use RAID, okay? I don't need parity, I don't need mirroring. We use parity and mirroring because we have an individual disk that could fail. Well, the disks I'm adding here at minimum at LRS, there's 3 copies of the data already. I don't need to waste more capacity using mirroring or parity, wasting disk and performance. It's just simple. They're just adding together. For SQL, I could use SQL's own file grouping. It can actually see multiple disks and use them, so I could leverage that. Now, one thing it does do is obviously gives me the combined IOPS as well. If I had 4 different disks, especially when we think about the bursting and other stuff going on, that might actually give me a higher IOPS than the capacity of one disk of that size. Normally it's fairly linear, but especially for some of the smaller ones, you get maybe a greater set of IOPS or throughput. Don't forget about the VMs limit though, remember? Yes, the disks have a certain set of capabilities. The VM also has its own limits. It can't go past those. Again, Ultra, because they're so big, 64 terabytes, 160,000 IOPS, probably not struggling. So just to finish with, I mean, I've talked about it a bunch of times. Azure Storage Explorer, it's free. Go and download storageexplorer.com. It's great. There is that version in the portal as well. It's a HTML5 based tool. I've been showing it throughout this entire presentation. I can connect using an account, and it can use Azure AD access. It can go and get access tokens, account keys to get the access to it. It brings just a really nice experience together. Works with blobs, disks, tables, queues, files. It does server-side copying. So there's an API. If I wanted to copy from one storage account to another, rather than it bringing the data to my machine and then copying it back up again, it copies it on the Azure server side. So data never comes to my machine, which would slow it down. It keeps it all on the server side. I love this tool. I use it all the time. Highly recommend it. There's also AZ Copy. This is a command line tool. Again, it can provide that server side copy. Now I'm using a command line. I can copy data to Azure Storage, from Azure Storage to AWS, from AWS primarily. I can set concurrency, so I can get multiple kind of streams going at once to increase my performance. It has a sync mode. This is really nice. Imagine again, I have those incremental snapshots. So it can just copy the changes. It can see what's there, what's on the source, and just copy the differences. If I have a massive amount of data, ideally we copy over the network. It's kind of the preferred model to use. But imagine you have so much data. Well, I can use import export. And what I can do is I can take my 2.5 or my 3.5 inch disks. We prepare them so they get BitLocker encrypted. I ship them off to the Azure data center and they copy it into my storage account. Or they put data on it and bring it back to me that I'm trying to get out of Azure. It's encrypted, as I said, using BitLocker. There's also Azure Data Box disk. So if I don't have disks of my own, Azure will ship me disks and then I ship them back with the data on that I want to get into Azure. If I have so much data, so my battery went flat, so super quick Azure Data Box, big appliance for shifting huge amounts of data, 770 terabytes at a time. For DataBox Heavy, 80 terabytes for the regular Azure Data Box, in and out. So I hope this was useful. This was massive. Any questions? Ask in the comments. Till the next one, take care.